All right, welcome to Chapter 3. We're actually getting into real physics stuff now. We're first going to talk about position and displacement. Our objectives for this chapter is to describe motion in one dimension using position, distance, and displacement. Analyze motion in one dimension using position, distance, and displacement. Correctly use and interpret positive and negative values of position and displacement. Here's your assessment. Robot car moves 200 meters east, turns and moves 600 meters west. Describe the motion using position, displacement, and distance. A woman starts at x is equal to negative 10 meters and has 3 successive displacements of negative 5 meters. What is her final position? What displacement moves an object from a position of 25 meters to a position of negative 15 meters? All right, physics terms for this one: origin, position, and displacement. Not very many. All right, equations. This is the displacement equation. XF will be your final displacement, is equal to xi, which is your initial displacement where you start from, plus whatever distance you traveled. The final position equals the initial position plus any other displacements. All right, describing motion. Before you can predict an object's motion, you need to be able to describe it. How do we describe an object's position? If the object moves, what is the difference between its distance and displacement? All right, click on the interactive on page 74 in your book. This interactive is going to show you objects moving through displacement in different positions. It's a good one to see the difference between distance and displacement. Engaging with the concept, initial position or final position can be entered here. So XO is going to be your initial position. XF will be your final position. Enter a displacement of meters. So the first distance you travel, they're pointing at here, is 5 meters. And you can put different types of meters. You can use positive or negative numbers here. Here they put a final position of 5 meters and the distance moved was 5 meters. And then for the second one, they added displacement of negative 10 meters. Hit enter. Final position is the distance moved is 15 meters. But if you look, the final position is negative 5 meters. So distance and displacement are different numbers. What is the difference between distance and position? Distance is always positive. It doesn't tell where you are because it has no directional information. What is the difference between distance and displacement? Displacement is change in position that includes direction. So what we're talking about here is displacement has magnitude and direction, making it a vector. Magnitude and direction, where distance is just magnitude, how far you've gone. So the final position equals the initial position plus any other displacements. So XF equals XI plus D. How is position described? In order to describe where something is, always begin deciding on an origin. All positions can be described by comparing them to the origin. Remember, on a graph we can have origins, where you have this being your origin of 0. It doesn't always have to be 0, though. Importance of the origin. The GPS system uses 0 latitude and longitude as the origin. So position tells you where you are relative to an origin. Positive and negative values tell you whether you're in the front or behind, or to the left or the right of the origin. If you look at our little graph here, this is our origin. And this is the positive direction, and this is the negative direction. How is displacement described then? To describe displacement, you must create a coordinate system and choose which direction is positive and negative. This is a choice. It may change for different problems. Most of the time, we use the same coordinate system that you see in a graph. For us right now, we're using right and east is positive, and left and west is negative. North and up is positive, and down and south is negative. Displacement is a change in position. Positive and negative values indicate direction. So you're seeing here you have a change of 20 meters because it moved from negative 20 to 0. Displacement is a vector because it has directional information and the number, the magnitude that goes with it. For motion along a line, direction is either positive or negative. So we have positive moving this way and negative moving to the left. Distance is a scalar quantity. It does not include the direction. For here, distance is going to equal 10 no matter which one you go, whether you go plus 10 or minus 10, because it does not have direction. So distance is just adding up all the different distances you traveled. Adding displacements. An ant starts at the 2 meter mark, right here, and crawls forward 7.1 meter, then turns around and crawls back 5.5 meters. What is the ant's final position? Adding displacements graphically by drawing vectors to scale. So it first went, this one, it went 7.1 meters, and then it went backwards 5.5 meters, so it went negative 5.5. The first vector starts at the initial position, which was 2 meters. The second vector starts at the end of the first position. So if you look at these, 7.1 plus negative 5.5, the final position, gives you what? So they're showing you started at x1 plus d1 is 7.1 plus d2 is negative 5.5, giving you 3.6. You can also use numeric addition. This is faster and more accurate. How do you recognize the initial position and displacements? Example, a boat sails 50 kilometers north and 800 kilometers south. What is the sailboat's final position? What do you choose as the initial position? Let the initial position be 0 kilometers, so xi equals 0. When nothing is said to establish a particular start, you may assume the initial position is 0. What are the displacements then? Well, your displacement 1 is 50 kilometers north. That's plus 50 kilometers. Then 800 kilometers south is a displacement of negative 800 kilometers. Displacements are movements, so words such as move, sail, run, and travel are clues. So you have a 50 kilometer displacement and a negative 800 kilometer displacement. How do you and then what is the final position? So xf equals xi plus d. So we started, our xf is going to equal 0 because our xi was 0, d1 was 50, and d2 was negative 800. So you have basically negative 750 kilometers, or if you wrote it as 750 kilometers south, that would also be correct. All right, a robot moves 200 meters east, turns around and moves 600 meters west. Describe the motion using position, displacement, and distance. This is your first assessment question. Think about it. I'm going to move on. Pause the tape. The robot car starts at the origin with a position of 0. It has a displacement of plus 200 meters east and then a displacement of 600 meters west. So if you look at it, 200 meters east, and then it turns around and goes 600 meters, so negative 600 meters west. The total distance traveled was 800 because 600 plus 200 is 800. So that's just the distance. A woman starts at x equals negative 10 meters and has 3 successive displacements of negative 5 meters. What is her final position? Well, if she starts at negative 10, your xi then is negative 10. And all 3 of these will be the same. So negative 10, negative 5, negative 5, negative 5 equals negative 25. So her final position would be the negative 25. What displacement moves an object from a position of 25 meters to a position of negative 15 meters? Ask for displacement given initial and final positions. So the relationship is your final is equal to your initial plus d. This is the same formula we've been using. The xf equals xi plus d. Well, the solution then, if we're looking for the displacement, we're looking for that d. So we subtracted xi to the other side, so negative 15 minus 25 equals negative 40. The displacement was then negative 40.